Hi, this is Kenny Lee, and let's talk about convex mirrors. Now, a convex mirror is bowed out in the center, and so the focal point is actually behind the mirror, as well as the center of curvature, or sometimes we call this the focal length, and that's the radius of curvature. And the relationship is that the radius of curvature, C, is equal to twice the focal length. So if this is 10, then that's 20, and all distances are measured from the mirror. Now we're going to focus on the ray tracing part, so we can use that to locate where the image should be. Our object is an arrow pointed up, because that way we can tell if our image is up or down, or pointed up or pointed down, so we can tell if it's upright or inverted. And so if we take this one, now there are several different rays you can draw. The main ones that I want to focus on are the one that is parallel to the principal axis, and that will get reflected from the focal point, and the one that's aimed towards the focal point that will reflect off parallel. There's a couple others we can draw, but these two will work pretty much in any circumstance. Whether it's drawn to scale or not, it'll give you a good idea. So I want to start off with this. So I want to draw a line from the top of my arrow to the mirror, and then it will reflect away from the focal point. So I'm going to line up the focal point and where that ray hits the mirror, and I'm going to draw the ray bouncing off. Let me make sure I get it in the right spot. It goes off that direction. But since I know kind of what's going to happen, I want to go ahead and do this. I want to draw a virtual ray. You usually use dotted lines for virtual rays, leading back behind the mirror along that same line. So the ray goes off that way, and this is the virtual side. So that's parallel focal point. So the next one is focal point parallel. So what I'm going to do is I'm going to line up the top of my object to the focal point. And I'm going to draw a line from the focal point, or from the top of the arrow, towards the focal point until I hit the mirror. That's when I stop. And that's going to reflect parallel to the principal axis. So it will reflect this way. Now if you look, that line and that line doesn't cross. And so that means this is going to be one that the image is going to form behind the mirror. So I've already got one virtual ray drawn. I want to draw the other virtual ray from this one. And when I move those, where those two cross, that's where the image is going to be. So the image is going to be somewhere around there. We'll use dots because it's going to be a virtual image. And it's upright. So it's virtual and upright. Now there are other rays that we can draw. There's one that we can do that if you line up the top of your object with the center curvature, what's going to happen is the beam of light is going to hit the mirror and bounce straight back. And so it's going to bounce back this way. But I can also draw that virtual ray coming back off this way, heading towards the center curvature. And if I draw it a little bit better, you can see that all three of them should cross right there. Okay? So let's see one more if we move the object in a little bit further and see if that makes a difference. Because we look at this, the image is smaller than the object, it's virtual, and it's upright. So let's see what happens when we move this in a little bit more. Here's another concave mirror, and the focal point, center curvature, and our object we moved in quite a bit right next to the mirror. But we're still going to do the same thing, parallel focal point, parallel. So I'm going to line up the top of my object with the mirror and draw a line from the top of my object until where it strikes the mirror. And then it's going to reflect away from the focal point. So it's going to reflect up in this direction. And then again, we're going to draw the virtual ray coming back. Virtual rays, we usually use dotted lines for those. Not bad there. That's parallel focal point. So the next ray is focal point parallel. So that means I want to line up the top of the object and the focal point. and draw a line from the top of the object until it strikes the mirror. And then from there, it's going to reflect parallel to the principal axis. So it's going to go off that way. These two won't cross in front of the mirror, but they will cross behind it because we're going to draw the virtual ray coming back behind the mirror. So we'll do that. So they cross right there. So here is my image. Oh, I should have made it dotted. And that is a virtual image because it's behind the mirror. It's made up of the virtual rays. It's upright. And it's still smaller than the object. And if we try that third ray that goes towards the center of curvature, where it will go hit the mirror and bounce back off, but the virtual ray keeps going. Again, they all cross right about there. So that's it. Again, now, with a convex mirror, the image is always going to be virtual, it's always going to be upright, and it's always going to be smaller than the object. A good example of these are security mirrors that you see, or mirrors that they put so you can see around corners like in hospitals or in factories. Those are all convex mirrors. If you notice, the image is always smaller and upright. They use a similar one as the passenger side rear view mirror of your car. That's the one that says object and mirror are closer than they appear. Because it looks smaller, our brain thinks it's further away, so they put that warning on there. Thank you for watching, and tune in again for more optics. Bye.